Hi, Chem110H. So I'd like to go over a few of the problems that were in homework 3, and um, our grader looked at questions 3, 5, and 8. And so in question 3, for the most part, you guys did fine, but some of you thought that phase changes have a change in kinetic energy associated with them. So in particular, your phase changes here in number 3 have to do with steam condensing to 100 degrees. Um, and here we're making bonds so that the potential energy in this particular guy is going to go down. We're making bonds, and here we're breaking bonds. It's the reverse. So the potential energy is going to go up, but both of these are at constant temperature, and that means the kinetic energy doesn't change. So just just keep that in mind in those two guys, that you have delta T equals 0, so therefore delta KE equals 0. And in this particular one, you're making bonds, so the potential energy is going down. And in this one, you're breaking them, and so the potential energy is going up. Okay, so the next question was number 5, and everybody did well on that, so I'm going to just pop down to number 8, which seemed to cause more problems. So in number 8, we're told that there's two identical chunks of dry ice, and that they evaporate completely inside two identical Erlenmeyers. And that in one case, the flask is stoppered tightly, and in the other case, it's open to the air. So the first thing I do whenever I see a problem like this is I make a little sketch. And so I'm going to go ahead and do that. Okay. And so in one of these, it's open to the air, and then in the other one, it's identical, but it's stoppered. Okay. And there's a chunk of dry ice in here. And we know what happens. That's going to sublime, and it's going to become a gas. And so the first question that we have is concerns whether or not delta E is the same for both flasks. And this is you can put a lot of thought into this, or you can simply say, well, delta E is a state function, and it doesn't matter whether I have my system here. You can think of this first one as your constant pressure. Why is the pressure constant? Because it's coming from the pressure of the atmosphere, and it doesn't build up. And I can think of this as my constant volume. And why is the volume constant? Because it's stoppered. Okay, but here the pressure is going to increase, and because the volume is constant. And here, because the pressure is constant, the volume is going to increase. Okay, so you could imagine that there's a balloon, say that there's a balloon over the top of this, and as this piece of dry ice sublimes, then what would happen is that balloon would fill with the gas, the CO2 gas. Okay, so the thing that we need to think about is that you're going to observe a certain amount of heat in each of these experiments, and in this one, the heat that you observe is going to be Q sub P, and in the constant volume, the stoppered flask, it's going to be Q sub V. So we're going to observe delta H here, because Q sub P is delta H, and here we're going to observe delta E. Now, with that said, is delta E the same value for both flasks? Absolutely. Over here, the observed heat is delta E. The observed heat is delta H, but delta E is still the same number because delta E is a state function. So for which flask is Q equal to delta E? It's the stoppered. Going to C is the amount of heat transferred to the open flask, a state function. Well, here's the open flask. We can put a balloon on it. It's still open, okay, because in a sense, because the balloon will expand, allowing the pressure to stay constant and equal to P atmosphere. So for the open flask, this one, the amount of heat transferred, state function, well, the heat transfer is delta H. Delta H is a state function, so the answer to C is yes. And then for D, for which flask is the value of Q larger? Well, we know this one's delta H and delta E, so now what we have to do is compare delta H and delta E. And we know how to do that. I'll do it down here in this white space. Delta H is equal to delta E plus P delta V, and when there's a change in the number of moles of gas, it's delta NG RT. And delta N G here is going to be positive because we are making gas, and so as a result, delta H is going to be bigger than delta E. And so when we go back to the question here, for which value of, for which flask is the value of Q higher? Well, since delta H is going to be bigger than delta E because we're going to add this number to it, it'll be the flask for delta H, so it will be the open flask. I hope this was helpful. Thanks for listening. Bye-bye.